groups of drones. These systems have a huge potential to impact our lives, but they also have significant technical challenges, and one of them is precisely that they generate large amounts of data that has to be processed online for decision making, while only having limited computational power. So this motivates the use of decentralized control and estimation architectures, which basically means taking decisions based only on partial information, and this is precisely what my poster is about. So how can we design these decentralized controllers, and precisely what is the effect that uncertainty in both measurements and models plays in the centralization of the architectures. Thank you.
Hello everyone, my name is Alejandra Avalos. I'm a postdoc at Dana-Farber Cancer Institute at the Harvard Medical School. So I'm going to talk about designs that incorporate external sources of information into the clinical studies. That can be studies from previous trials, previous completed trials, or data collected from the outside the clinical constraints like electronic health record. The use of such data will help us to actually allocate more patients into the new drugs or treatments that we would like to study, and less people into the placebo or the ones that are having the standard of care. This will allow us to accelerate the drug process. However, this is not a straightforward task, and I will talk about this in my poster, so come and see if you're interested.
Hi, my name's Sarah, and I'm going to be presenting today on a work called On the Cost of Regulating Social Media. So in 1996, we had this Communication Decency Act passed, which essentially said that social media platforms aren't responsible for the content that others post on it. And this actually gives more protections to content providers than it does to citizens under the First Amendment. But we also saw that Facebook in 2019 was penalized $5 billion, and while this was a really huge step, I'm going to argue that it's not an indicator that regulation is to come, because this penalty was based off of a voluntarily signed order. And so right now, because of these two this dichotomy, we're going to see probably self-regulation in the near future. And self-regulation is currently focused on removing content that is inappropriate, discriminatory, or false. But the process of determining whether or not something is one of these three is really highly subjective, so one can justify wherever one decides to draw the line. And so I'm going to argue that not only are these highly subjective, but not necessarily the right problem to be addressing. And so our work is mathematically modeling the effect of social media on user learning and behavior, and we want to show that regulation can be achieved at low cost when it in a sense adds content diversity. Thanks.
Buildings account for 40% of primary energy uses in the US and about 10% of greenhouse gas emission. So addressing the energy efficiency of the building sector is going to be important in any climate action plan. One popular standard in the US to improve building energy efficiency is LEED, Leadership in Energy and Environmental Design. However, there is very little agreement in literature about whether LEED actually improves building energy efficiency empirically. So in this work, we use newly available building energy use benchmarking data from cities to conduct the first cross-city comparison and evaluation of LEED effectiveness at in building energy efficiency. We find that LEED is effective by improving building energy efficiency uses, but it might not be at improving GHG greenhouse gas emission efficiencies.
Hi everybody, my name is Marwa Al-Habi and I'm a postdoc at MIT. I'll be presenting something called a non-sum water minimization. So I look at problems that are set function minimization, where we have some ground set of elements and we're interested in selecting a subset of them that minimize some cost, which is represented by a set function. Solving this kind of problem is very hard, even to get any kind of approximations, but what people have shown is that if the objective has a nice mathematical property called sum with variety, then they can be solved efficiently. However, a lot of applications in practice doesn't have this property exactly, but they're close to having it in some sense. And then the question becomes, can we do better than the worst case for these kind of approximately submodular functions? So this is our work is the first one to look at this question, and to know the answer, come to our poster. Thank you.
Hi, my name is Julia Gaudio. I'm a PhD student at the MIT Operations Research Center, and this is Luca. To motivate the problem, imagine you are trying to estimate the price of houses from such things like their size or their distance to downtown. A reasonable assumption is that, all things being equal, a larger house would be more expensive. That's an example of a monotone function. So with my advisor, we considered the problem of estimating monotone functions, known as the isotonic regression problem. We also introduced a sparse version of the problem and provided algorithms for function estimation.
Hi everyone, my name is Leilani Gilpin. I'm just finishing up my PhD at MIT, and I'm interested in what happens when complex machines fail. So as a lot of people probably know, we've had a lot of autonomous vehicle accidents with machines that are prone to uncertainty and making decisions with large errors. One of the most difficult things is that these complex machines have no ability to explain what they did or backtrack their decisions. So I came up with a methodology to represent a complex machine like a self-driving car, or even your operating system, like an organization of hierarchical parts, similar to the way that some of our organizations and committees form. And then I use that with a symbolic explanation language to facilitate better decision making that is explainable and also organized in a way that you can sort of backtrack and find the localized error. If you're interested in this, please come to my poster. Thank you.
Hello, I'm Christina Lovento. I'm a PhD student at Harvard, and I will be talking about implementing differential privacy in practice. And in general, when we think about differential privacy, particularly mechanisms like Laplace, we think about arbitrary precision arithmetic, like we can write down the number e. Obviously, we can't do that, and in real life, we have to live with floating point. So in this poster, I'll present some novel attacks on naive implementations of the exponential mechanism, and show how to implement it exactly with base 2 differential privacy, which protects you from all of these types of attacks. And I'm happy also to explain more about differential privacy if you're curious. Thanks.
Hi, I'm Haley. I'm currently a machine learning engineer at LenBuzz. This is some of my work when I was at Harvard. To give context, word embeddings use shallow neural networks to create a vector representation of every word in a given vocabulary. They're trained on a large corpus of data, such as all of Wikipedia or the New York Times, and because of this, they incorporate the biases in their data. So for example, if you're using cosine distance to create word analogies from the resulting vector representations, you'll get a word analogy like man is a computer programmer, as woman is a homemaker, the title of a recent paper in this area. Methods have been proposed to mitigate this kind of word embedding bias, but recent work has shown that these methods fail to truly remove the bias, but instead are hiding the bias, which can be recovered through nearest neighbor statistics. We propose a method for mitigating the bias in these word embeddings, which leverages the probabilistic nature of the word embedding algorithms. So you can learn more if you come to my poster.